DLR is working on most components of the stack, and for example, we are producing or trying to produce a microporous layer on top of the PTL that will come from Beckert. And also underneath of the PTL, we're trying to improve the transport properties. So that means we are introducing a gradient structure until we will then reach the bipolar plate, where we maybe have a flow field or maybe not. So this will be decided in the project, but we will heading for innovative technology. And Wendelin is mainly designing from here. So
the bipolar plates is where I'm starting, and including the bipolar plates, of course, there is the gaskets, which are very important, which are playing a very important role in the whole stack design. And if we look at the stack itself, so there is then the end plates and the current collectors, which have to be designed in a proper way, because if you look at the size of the membrane that we have with 400 square centimeters, we have to deal with 800 amps. So designing the end plates and also the current collector is a very important part of it. Mass transport problem in the stack, of course, or in the electrolyzer in general, is challenging because of the two-phase flow that we are facing here. And once there is gas, and the other is the electrolyte, liquid electrolyte. So once we want to get the water to where the reaction zone is, and on the other hand, we need to get rid of the gas, which needs to be driven out of the stack. And therefore, we are developing with 3D modeling and with simulation some bipolar plates that are specially designed for the size of the membranes that we're using here. So mass transport, of course, does affect the performance of the stack, and therefore...
Yes, so for example, when you have bubbles at the surface of the catalyst layer, it's completely blocking the electrochemical performance, so we really get rid of these bubbles. And for that, we might introduce a microporous layer that better moves out the bubbles. And we will have then a gradient structure heading to the flow field that was Wendelin introducing.
We do testing on different levels. So this means starting from single cells to short stacks. And then later we gain a sufficient experience with that for designing the final design of the prototype. So then at the end we build up the prototype, and then testing is going to be performed, and then finally at the end we will find out what exactly the performance will be like.
Yeah.
There are some differences and some innovation that we're bringing in here, so we're quite excited how to test it and to see how it performs.
Yes.
Assembling the stack is not that easy, so it's not only stacking components on top of each other. We definitely need some kind of jigs, and this is something that we are designing in parallel, which means that there must be some handling devices applied here for a precise positioning of the components, which is very important. And of course, we need to do this in a proper way. And then once we have stacked all components on top of each other inside of this jig, then the compression force needs to be applied via the end plates. And also this must be monitored very well, because it also affects the performance of the stack.
What we will test is definitely if the whole stack is gas tight, and but the final testing will be then increased.
Important to say that all of this design process is an iterative way. So once we design one component, then we do simulation and we find out we need to make some changes. And these changes affect all other components, like, for example, gaskets and shapes of bipolar plates and so on. So this is like a floating process, yes, until we get to a product of which we think this is a really optimized design that we are going to apply here, and then we start the production process. And some parts we're producing ourselves, which in the range of designing a prototype is possible, while we're always thinking of how can this be transferred in a series production so that later in the end we're not ending up with a system that is performing nicely, but there is no way of producing it. So this is always two tracks we're following, and then at the end we end up with a prototype that is representative in terms of mass production, and we're always looking at costs.
Yes.
So this is a very important fact also here in this project.
So yeah, like Wendelin said, it's very important that we have a look at the euro per kilowatt. This should be quite low, that we can have a nice innovative stack that can also be sold and help growing for the hydrogen community.